Okay, so which row of the table is correct? Ammonia molecule, ammonium ion, ammonia molecule, and ammonium ion. So we need to draw a structure of ammonia molecule. So ammonia molecule have 1 lone pair, 3 bond pair. So it will make a shape with 1 lone pair and 3 bond pair. We have a shape of pyramid. So we have a pyramidal shape. And when this nitrogen share its lone pair with hydrogen, it becomes ammonium ion. And this ammonium ion, you can see it has a pyramidal structure and it has a tetrahedral structure. Now, one thing to identify sigma bond, a single bond is a sigma bond. So you can see they all have a sigma bond. So option A is correct, but at the same time, if we write its configuration, we know that to make sigma bond, we need hybrid orbitals. So this nitrogen is sp3 hybridized, this nitrogen is also sp3 hybridized, so they have a sigma bond. Question number 1. In this sodium chloride lattice, the number of chloride ion that surrounds each sodium ion is called the coordination number of the sodium ion. What are the coordination number of the sodium ion and the chloride ion in the sodium chloride lattice? So this question is very simple. You just need to know the structure of sodium chloride. As you all know that sodium chloride has a cubic lattice. So if we draw a cube, and it has a alternative sodium and chloride ion, if we draw a unit cell of this lattice, sodium chloride lattice, if we have a sodium ion here, we have chloride ion here, chloride ion here, so now how can we know that sodium ion is surrounded by a 6 chloride ion? For this we need to complete this diagram. If we extend the line, see, so you can see that this sodium ion is surrounded by this chloride ion, and here chloride ion, and at this point chloride ion. So you can count it. It is 1, 2, 3, 4, 5, and one more place 6. See, so this sodium ion is surrounded by 6 chloride ions. So this option may be correct, this option may be correct. Now we need to know about chloride ion. So if you extend this chloride ion again, lines of, see, this is chloride ion. If you extend this chloride ion, line 1, 2, and 3, and just place the ions. It is surrounded by sodium ion, sodium ion, sodium ion. So you can see, you can count it. This is 1, 2, 3, 4, 5 and 6. So this option is a correct option. C option is a correct option. Okay, for this question, the boiling point of methane, ethane, propane, butane are given, and you can see gradual increase in boiling points, and one of the thing or a trend you can say that as the chain length increases, boiling point increases. So option number 1, closer packing of molecule result in stronger van der Waals forces. But the reason of higher boiling points are van der Waals forces. So we will find that statement which defines increase in van der Waals forces increase the boiling point. And how van der Waals forces increases? There is a one point that states that instantaneous induced dipole forces increases with increasing number of electrons in the molecule. And this statement is given here. More electrons in the molecule results in stronger van der Waals forces. As you can see, chain length increases, molecular mass increases, and number of electron obviously increases. So this is the one of the factor which increases van der Waals forces. And van der Waals forces are the cause of increase of boiling point. I hope you understand. So option C is correct and the rest of the options are incorrect. Okay, for question number 3, the characteristic smell of garlic is due to alene. What are the approximate bond angle X, Y, Z in a molecule of alene? So you need to find angle between CH double bond. So this carbon is sp2 hybridized. So it is this carbon as a structure So if we find bond angle here, we are finding X, and you know if it is sp2 hybridized, it has a angle of X is equal to 120, 120 and 120. Now come to the next one. This is again, this carbon is also sp2 hybridized, and we need to make in a similar manner like this, and we understand it very well that the angle Y, which is written here, angle Y, it's between carbon and another carbon. Carbon and hydrogen, let me write. It's hydrogen. Hydrogen. It's carbon. And then we will talk about carbon after writing this. They are asking about this angle, C and C. So you know, you can easily now find or predict it is 120, right? So your Y, angle Y, which is between C, H, C, it is 120. So both angle are 120. Now come to carbon, which has its 4 valencies utilized. So for this kind of carbon, which has 4 valencies, shows that it is sp3 hybridized. sp3 hybridized means 1H here, 1H here, and this is in a direction. So next is sulfur, and again it has a double bond. So when there is a double bond, the angle between them is here 120, 120, 120, although they didn't ask about it. Okay, now again we have a carbon here, carbon, and carbon, all valencies are utilized, so it is tetrahedral structure, and it is again sp3 hybridized. And this carbon is directly connected with the carbon, and again this carbon on one point have NH2, and with one it has H, and with one carbon it has COOH, carboxylic acid. So you can see the angle between CH2 and NH2 here to here, this side, see, it is again 109.5 because it is tetrahedral structure. Okay, so carbon to nitrogen angle they are asking about, from this carbon to this nitrogen, it is tetrahedral. So option C is a correct option. I hope you understand. Okay, question number 4. Sodium azide is an explosive used to inflate airbags in cars when they crash. It consists of positive sodium ion and negative azide ion. What are the number of electrons in sodium ion and azide ion? So basically it is very simple question. Sodium ion, you know, it carry 1 plus charge, and azide mean 3 nitrogens and 3, and definitely it carry 1 minus charge, that is why it become Na N3. Now we need to find their number of electrons. So sodium, proton number of sodium is 11, and when it loses 1 electron it becomes 10. In a similar manner, nitrogen, proton number of nitrogen is 7, and there are 3 nitrogen here. When we multiply it with 3, we get 21, and 1 electron which has been lost by sodium, this 1 electron is accepted by this, and it becomes 22. So the answer is B, 10 and 22. Well, this question is about bond angles. Histamine is produced in the body to help fight infection. Its shape allows it to fit into a receptor which expand blood vessels. So here you need to find bond angle, but for finding bond angle you need to draw a diagram. Like if you need to find nitrogen has a lone pair, so for it has a shape like this, and here if carbon is attached, you know, if there is 1 lone pair and 3 bond pair, it has a bond angle of 107. So here the bond angle between this is 107. Now here carbon is attached, and carbon, all valencies of carbon are utilized. It means carbon is sp3 hybridized and it has tetrahedral structure. See, and it is again attached to a carbon, and you can make it displayed form. Carbon is attached with another carbon, and again it has 2 hydrogen, so Y is between this and this angle, so this and this angle is what? It's 109.5. This is Y and this one is X. Now come to the ring. This carbon CH2, after CH2, this carbon is basically in the ring. Carbon, here nitrogen, and you know when carbon is sp2 hybridized, it has a bond angle of 120, 120 and 120. So here Z is equal to 120. It's 120. So this is 107, this is 109.5, and this is 120. 120 angle. So smallest bond angle is 107 and it is X, and then 109.5 it is Y, and the largest bond angle is Z. So option A is a correct option. Question number 7. Which diagram describes the formation of a pi bond from the overlap of its orbitals? So you can see that we have orbitals, type of orbitals. One is called s orbital. See, s orbital and another s orbital when they overlap on. So they have complete overlap, and you know what? They become their overlap make their shape in this manner. In a similar manner, if we have px orbital, see, this is one px orbital and this is another px orbital. When they overlap, they will make sigma bond. See, you have a sigma bond here, you have a sigma bond here. Sigma bond is basically formed by axial overlap. You can see here you have a axial overlap, and these are two y orbitals. See, py orbital, this is py orbital, and they only overlap in a parallel way. So this is called pi orbital. You can see this is called pi bond, which is formed by parallel overlapping. They are basically asking about pi bond. So again, this is a sigma bond, px orbital and 1s orbital, they overlap and they make sigma bond because it is again axial overlapping. But D option is a strong distractor, and it is wrong because it is not s orbital, it is not px orbital, it is not py orbital, it is not pz orbital. And you know, pi bond are only formed by orbitals which are on y-axis or on a z-axis, which is formed by the parallel overlapping. So which one the answer? B option is a correct option. Okay, so this one is a wrong because it is not a shape of any orbital. Question number 9. Lycra is a polyurethane fiber used in fashion industry. It is a polymer made from two monomers, one from which has the following formula. Which is the OCN bond angle in this molecule. And for determining bond angles, you need to remember that one consideration which you make during determining the shapes of molecule, that if you have a double bond or if you have a triple bond anywhere, in any case, you will consider it single bond pair. So again, listen, if you have a double bond or if you have a triple bond, you will consider it a single bond pair to determine a bond angle. So if we want to determine bond angle, we have a central atom carbon and it has two bond pair and there is no lone pair over it. So a molecule which has two bond pair plus zero lone pair, they have linear structure and their bond angle is 180. So option D is a correct option. Okay, this question is about intermolecular forces and it is about a crystal of iodine produce a purple vapor when gently heated. Which pair of statement correctly describes this process? Iodine in its solid form converted into iodine gaseous. So process of sublimation occur. And what type of bonds are broken when iodine solid converted into iodine gaseous? So first of all, we need to draw a diagram for iodine. This is iodine molecule. And when iodine is solid, it is in its crystal form. So they are like this. And what are these forces through which they are joined together? These are iodine molecule and they are connected through induced dipole, as the molecule is a non-polar molecule. Induced dipole-dipole interaction. So when you heat this iodine lattice, what happened to these iodine molecules? They will be converted into gaseous iodine. So what type of bonds are broken? So you can see type of bond broken, induced dipole interaction, and formula of purple species, it's I2. So option C is correct, and this is the answer, induced dipole and iodine particle. Okay, question number 11. Dicarbon monoxide is found in dust clouds in space. The structure of this molecule is here, and this molecule contains no unpaired electrons in it. So how many lone pairs of electrons are present in a molecule of C2O? Unpaired electron, no unpaired electron. So it means they have paired electron. So we need to complete the electrons of oxygen first. So if we write oxygen has 6 electrons in its atmosphere, and then we need to complete carbon. This is carbon, and this carbon also contains electron. So you can see we have one lone pair here, we have one lone pair here, and we have one lone pair here. So it has 3 lone pairs all together. Here, here, and here. Thank you. Which molecule contain at least one bond angle of 120 degrees? So C2H4, drawing the structure of C2H4. each carbon in C2H4 is sp2 hybridized. So in sp2 hybridization we get 120, 120. So its all angles are of 120. So which molecules contain at least one bond angle of 120? So this molecule contains one bond angle of 120. It's all bond angle of 120. Now check PF5. P five electrons of phosphorus is shared in this manner. So these are in one plane, and this is above and below. So the which are in a one plane, they have an angle of 120, 120 and 120, and above and below they have angle of 90 degree. See, so 90 degree and 90 degree. So it has an angle of 120. But in case of NCl3, you can see this is correct also. Now for NCl3, N has one lone pair and it will share its electron, 3 electrons with chlorine. So see, it has one lone pair and 3 bond pair. It has pyramidal shape and it has 107 angle. So this will be out from options, and we will have answer 1 and 2. Option 1 and 2. B is the right answer for this. Question number 14. Phosphorus forms 2 chloride. Phosphorus trichloride is a covalent liquid and phosphorus 5 chloride is an ionic solid. One of the ion present is PCl4 plus. What is the shape of PCl3 molecule and the PCl4 ion? So if we draw a diagram for PCl3, P belongs to group number 5. It has 5 electrons in its outermost shell. 1 is shared by each chlorine. So on central atom we have 1 lone pair and there are 3 bond pair. 3 bond pair plus 1 lone pair make trigonal pyramidal shape. So it has a pyramid like shape and angle of 107. So we have A option and B option, so they will be ruled out. Now what about PCl4? PCl4, this one of the electron pair will make dative bond, and this diagram will be modified further into PCl, one dative bond with another Cl, and it become tetrahedral structure. So option B is a correct option. If you write its configuration, it become sp3 hybridized and it has a tetrahedral structure. So option B is a correct option.